Good day, dear viewer. We are the Density Detectives, and today we embark on a special mission, Operation Unmask. Our task is to uncover the hidden truths and reveal the mysteries behind everyday objects. Get ready to follow the clues, connect the evidence, and discover what lies beneath the ordinary. According to our case file, the mission briefing is clear: to measure the density of various kitchen materials using scientific methods, and to explore how density affects real life. With our tools as our magnifying glass, we're ready to crack this case wide open.
Our mission is clear: detective partners to uncover the secret identities of everyday material. What may look ordinary on the surface might hold hidden truths waiting to be revealed. Mass, volume, or density. No object can hide its true nature from us.
Evidence collected. The materials are now secured and ready for investigation.
Alright, detectives. First up, weighing the suspects. We need to know the mass of each material to crack this case. We're going to use a scale to determine the mass of the chosen object in grams. Next, we measure their volume. Volume is key to unlocking their true identity. We're using our trusty measuring cup to determine how much space each suspect occupies. Accuracy is crucial, so keep a close eye on those measurements. For liquids, uncovering their volume is a simple ordeal. Simply pour the substance into a measuring cup and check the labels to determine the volume in milliliters. For irregularly shaped objects, we must submerge them in water. Some suspects don't give up their secrets easily. By measuring how much water they displace, we can calculate their volume even if they're oddly shaped.
And now for the moment of truth. Expose their true density. With the mass and volume in hand, we can finally reveal what they're really made of using the calculator to plug in the values. No lies survive the formula. It's time to put those numbers to work and uncover the hidden truth. And speaking of formulas, the formula we will be using to solve this case is density equals mass over volume. Through this process, we will be able to discover the densities of our chosen suspects. Now, we will give the floor to the prominent detectives in charge of gathering the evidence.
Good day, I'm Detective Shello, tackling sugar here. In the kitchen, sugar is the master of disguise, blending seamlessly into cookies and coffee, while in the lab, it's a molecule of intrigue, hiding its complex structure behind a veil of sweetness. Sugar always leaves a trail of energy and delight, but too much of it can lead to a sticky mystery. As per our procedure for investigation, the sugar revealed a mass of 345 grams and a volume of 320 milliliters. Using our trusty formula, we calculated its density to be 1.08 grams per milliliter. Next, we have rice, a staple food in many Asian households, a suspect that hides in plain sight. Its mass was 367 grams and its volume was 360 milliliters. This gave us a density of 1.02 grams per milliliter. Detectives, we compared our final densities for sugar and rice to the standard values and found they were a bit higher, which is 0.80 to 0.90 grams per milliliter for sugar and 0.75 to 0.85 grams per milliliter for rice. This is because we measured bulk density, which is affected by how tightly a material is packed. When we filled our cups, we created fewer air gaps, leading to a higher density. We also have to consider human error and potential inaccuracies in our measuring tools. Ultimately, the results prove that a material's density can vary depending on the conditions of the investigation.
Our investigation continues with two more suspects, flour and oil. Our case files show some interesting clues. Don't worry, for I Detective Choriz is on the case. First, the flour weighed in with a mass of 525 grams and a volume of 190 milliliters, giving it a calculated density of 2.76 grams milliliter. Next, the oil had a mass of 179 grams and a volume of 170 milliliters for a calculated density of 1.05 grams milliliter. Detectives, our calculated densities for both oil and flour were higher than expected. The oil's density is slightly higher. Could be that it's a liquid with a moderate density, or that it contains air pockets. For the flour, the density might be because it was packed tightly because of the moisture, or it was mixed with something denser than usual, since the regular flour is much lighter. Also, there could be small errors in how the measurements were taken, such as it being pressed down or the volume being measured incorrectly. Even though these values are higher than what's typical, they still make sense because the way the evidence is handled or measured can change the results of the investigation. There will always be slight variations.
For our final case file, this time I, Detective Aspia, will be guiding you on the case of the lemon. The evidence collected had a mass of 163 grams and a raw volume of 140 milliliters from a measuring cup. Our mission required a deeper analysis. Because a measuring cup isn't as precise as a graduated cylinder, we accounted for a 10% error range. This gives us a possible volume from 126 to 154 milliliters, which reveals a density range of 1.058 to 1.294 grams per milliliter. Now, for the final piece of the puzzle. Our findings for the chilled lemon line up with the known average density for lemons, which is around 1.05 to 1.07 grams per milliliter. The slight increase in density is a clue. It proves that temperature affects density. This higher density is also why a chilled or frozen lemon, being slightly heavier than water, might sink rather than float if in a container with an amount of water that is able to submerge it.
The evidence is clear. On this table lie the suspects: sugar, rice, flour, oil, and lemon. Each was weighed, each measured, and each compared against their true identities and their standard densities. Let's uncover the truths they tried to hide. First is sugar. It weighs 345 grams and had a volume of 320 milliliters, giving a density of 1.08 grams per milliliters. The standard range for sugar is between 0.80 and 0.90 grams per milliliters. Why the difference? Simple. Fewer air gaps in the crystals. The sugar was pressed tightly, hiding less air but revealing more weight. Next came rice. It held 367 grams of mass and occupied 360 milliliters of volume, resulting in a density of 1.02 grams per milliliters. However, the standard range for rice is only 0.75 to 0.85 grams per milliliters. What happened here? The grains were packed tightly, leaving no empty space. Rice was guilty of being too compact.
Flour was next. With 525 grams of mass and 190 milliliters of volume, its density was a shocking 2.76 grams per milliliter. The standard range? Only 0.59 to 0.65 grams per milliliter. Something was definitely off. Perhaps moisture weighed it down, or it became compressed over time due to sitting in the cupboard or pantry. The conditions of the flour prior to it being weighed plays an important role in its measured density. And in any case, flour was the heaviest suspect of them all. Then oil. It had 179 grams of mass and 170 milliliters of volume, yielding a density of 1.05 grams per milliliter. Typically, oil floats between 0.91 and 0.93 grams per milliliter, slightly higher than expected. Could it be air pockets? Bad measurements? Oil was slippery as always, hard to pin down.
Finally, lemon, with a mass of 163 grams and a volume of 140 millimeters. Its density ranged between 1.058 and 1.294 gml. The standard range is 1.05 to 1.07 gml. For once, the suspect matched the record. When temperature was considered, lemon was the honest one in the lineup. So, the case is clear. Sugar was dense with fewer gaps. Rice was tightly packed. Flour weighed heavily with suspicion. Oil slipped past the standard, and the lemon was the closest to the truth. In the end, every suspect's story was written in numbers, a table of truths they could not escape.
But detectives, our investigation isn't just about the number in labs. The principle of density is a silent force operating all around us, cracking sense in the real world every single day. Take maritime forces. For example, a massive ship like an oil tanker is a puzzle of density. Its hollow design creates an overall density less than water, allowing it to float. But if it takes on water from a bridge, its mass increases, and its density changes. If it becomes denser than water, it sinks. Calculating these densities is a matter of life, death, and environmental safety.
Or consider air travel. Why does a hot air balloon rise? It's a classic case of density. When the air inside the balloon is heated, the molecules spread out. This means the mass of air inside the balloon decreases, making it less dense than the cooler, heavier outside. The principle of buoyancy takes over, and the case is solved. The balloon must rise. It's a perfect demonstration of how temperature directly affects density, just like with our lemon. Even in the kitchen, density is at work. Think of a layered cocktail or a lava lamp. These are visual proof of different densities at play. The densest liquids sinks to the bottom, while the least dense floats on top. By understanding density, chemists and engineers can design everything from effective medicines to efficient cooling systems. So you see, the mystery of density is not confined to our lab. It is a fundamental clue to understanding our world.
Every good detective must file a final report, and the conclusion of this investigation is clear. Density is not just a number to be calculated. It is a fundamental property of matter, a silent clue hidden within the fabric of everything we see and touch.
Our mission in the lab was a microcosm of the world. The same principles that governed our sugar and rice, the interplay of mass, volume, and the spaces in between, are the very principles that shape our reality.
So, the next time you see a bird soaring on a thermal updraft or taking a sip of a beautifully layered drink, remember, you are witnessing a case of density in action. The world is full of unsolved mysteries, not with malice, but with science waiting to be uncovered.
Our investigation may be over, but the clues are all around you. We challenge you, the viewer, to become density detectives in your own life. Ask questions, observe the evidence, and uncover the hidden truths in your everyday lives.
Every clue uncovered showed us this density isn't just numbers. It decides how the world works around us. Misjudge it, and mistakes follow. Understand it, and you hold power over the ordinary.
With that, we've wrapped up the case. For now, always keep your eyes peeled, detectives. Thank you for coming with us on this educational excursion.